In this chapter, students will focus on using the equivalent fraction strategy for adding and subtracting fractions. Students will find equivalent fractions on a multiplication table. In previous grade levels, students have formed a basis of understanding fractions and have been taught various skills with which to allow them to be successful with the skills and concepts taught in this chapter. The first skill students learned was that the equivalent fractions can be created by multiplying the numerator and the denominator by the same factor. They related this to a model. If the numerator and denominator of 1/3 is multiplied by 2, the equivalent fraction is 2/6. Students learn that fractions and mixed numbers can be composed and decomposed in a variety of ways. This skill led the students to understand that fractions can be built from unit fractions. Adding fractions is the process of joining unit fractions. 5/8 is 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. Students added and subtracted fractions and mixed numbers with like denominators in a variety of ways. 5/6 plus 3/6 is 5 6-size pieces plus 3 more 6-size pieces for a total of 8 6-size pieces. Let's begin with the skills and concepts taught in this chapter. The first skill is adding and subtracting fractions with unlike denominators. One strategy is to reason about and estimate sums and differences of fractions. For example, 3/4 plus 1/2. Students may decompose 3/4 into 1/4 plus 2/4. Now the expression reads 1/4 plus 2/4 plus 1/2. Students may then reason that 2/4 is the same as 1/2, and 2/2 make a whole. The expression now reads 1/4 plus 1/2 is 1 1/4. The rest of the strategies focus on finding common denominators in order to add and subtract the fractions. Students will recognize that same-size pieces must be considered before adding or subtracting. Another strategy students will learn is looking for related denominators. For example, 9/10 subtract 2/5. Let's model using a number line. The first number line will represent 9/10 and the second will represent 2/5. In order to show 2/5 on the same number line as 9/10, a common denominator must be found. The denominators 10 and 5 are related. 5 times 2 equals 10. 2/5 can be multiplied by 2 to get an equivalent fraction of 4/10. This is shown on the number line by dividing each 1/5 size piece into 2 10th-size pieces. 2/5 is now equivalent to 4/10. 9/10 minus 4/10 equals 5/10. Another way students explore finding common denominators is using a multiplication chart when the denominators aren't related. Let's look at the expression 3/5 plus 2/8. Let's highlight the multiples of 3 with one color and all the multiples of 5 with another color. Students will notice that the highlighted multiples show equivalent fractions for 3/5. For example, the first set is 6/10, then 9/15, and so on. Next, highlight the multiples of 2 and the multiples of 8. The next step will be to find common denominators between the 5ths and the 8ths. The first denominator they have in common is 40. Looking at 3/5, if the denominator is 40, that is the 8th multiple of 5. So the 8th multiple of 3 is 24. The equivalent fraction for 3/5 is 24/40. Looking at 2/8, 40 is the 5th multiple of 8, and the 5th multiple of 2 is 10. The equivalent fraction to 2/8 is 10/40. Now that the fractions are measured by the same size pieces, they can be added. 24/40 plus 10/40 equals 34/40. In looking at the addend of 3/5, the numerator and denominator were both multiplied by 8, which is the denominator of the second addend of 2/8. Also, the addend of 2/8 was multiplied by 5, which is the denominator of the first addend, 3/5. In general, students will understand that a common denominator can be generated by multiplying the denominators of the given addends. They may recognize that in some cases it is more efficient to find a smaller common multiple to use as the denominator, but it is not necessary. In this chapter, students will find equivalent fractions by finding common denominators in order to add and subtract fractions and mixed numbers. Students will continue to use a variety of models as well as a multiplication chart in order to solve real-world problems to support their understanding of fractions. It is important to avoid the temptation to simply present one algorithm for a given operation. Providing students with opportunities to develop a conceptual understanding of operations with fractions provides students with the insight as to why a given algorithm works.